Hey guys, welcome to Astronomy, September 28th, 2018, with me, your host Christian Harris. Let's go ahead and get started. Now, to anyone who's watched Mr. Astronomy before, perhaps on Snapchat, you might be a little confused as to why I'm on YouTube now. Well, just a brief backstory on that is that Snapchat is not very productive for getting new followers, since it's a private messaging app. You can't just discover new people on Snapchat unless they're paying money to be promoted. So I decided to move to a more open platform such as YouTube. So that's why I'm here, and why I'm starting Mr. Astronomy back after not doing it for about 7 months is it's the 2-year anniversary. So I figured, why not start strong and do a great episode on a common misconception. What would happen if you went into outer space without any protective gear? So what would happen if you just waltzed out of the airlock chamber on the ISS without any protective gear? Would you explode or implode? Would you overheat? Or would you freeze to death? Well, none of those. You'd suffocate, given that you only have 30 seconds to a minute 30 seconds of oxygen in your lungs. So, for the sake of the episode, let's just say you have an oxygen mask with you and nothing else. What would happen? Well, given that space is a vacuum, we always think you're going to explode. All your blood and everything inside of you is going to get pulled out by the vacuum, because when you put something in a vacuum, it expands. However, that's just not the case, because our bodies are air and water tight. However, if you were to cut your arm, your blood would literally boil. And I don't mean getting hot boil, I mean it would boil because of the lack of a boiling point. See, liquids in space cannot exist. They'll turn into gas because a liquid needs certain amounts of pressure to stay in its liquid state. So without that pressure, being in a vacuum, it will immediately boil. Some people have described the sensation of going into a vacuum chamber and opening their mouths like pop rocks on their tongue. It's very bizarre how liquids cannot stay liquids in a vacuum, but that wouldn't cause you to explode in space. There are 3 ways that heat can be transferred: through conduction, through convection, and through radiation. So let's get to conduction. We know that through conduction, or contact, heat can be transferred very easily. It's one of the most effective ways of transferring heat, such as if you put your hand on a hot stove, you're gonna get burned. However, in space, you're in a vacuum. You're not touching anything except the vacuum of space. But even then, you're only touching it, because there's nothing to touch. So you're surrounded by nothing. And as for convection, convection is kind of like conduction. There still has to be matter around you for heat to be transferred. Only it works instead through liquids and gases, unlike conduction, which is just through contact. Convection is a cyclical heat. You've got a heat source, heat rises, then loses heat, goes down, gets hot, goes back up. In space, there's no convection because you're not being touched by any gases or liquids, and there's no conduction because you're not being touched by anything. This isn't to say that there is no conduction in space. There can be. There's no law of physics that states there can't be conduction in a vacuum. It just cannot be committed from the vacuum to an object, because conduction needs one object and another object, and a vacuum is the lack of matter. So I keep talking about vacuums and how it's the lack of matter, and with no matter, there's no pressure, because pressure is just how much matter is compacted in a certain area. So what does that mean for a liquid in space? Well, when you take a liquid from a pressured environment to an unpressured environment, its boiling point is going to fall. So if you move a liquid to a vacuum where there is no pressure, it cannot have a boiling point. Its boiling point is instantaneous, because it's impossible for a liquid to exist in a vacuum. Some astronauts actually tested this by urinating in outer space. And what they saw was their urine boiled in the vacuum and then instantly froze. So why wouldn't this happen to an astronaut? Well, that's a simple answer. Our body is an airtight vessel. So our blood isn't going to boil, but some properties of why the urine boiled and then froze are going to be the same for us. So let's say we do walk out from the ISS into the vacuum of space. What's going to happen is you're going to get hot. I mean really, really, really hot. Have you ever been in a room that's 85 degrees without any air conditioning on, it's unbearable, at least for me. It's really difficult being in a room that's 85 or 90, but our bodies are supposed to operate at 98.6 degrees Fahrenheit. So why is this a problem for us? Well, that's a simple answer. Convection. Our bodies in a 75 degree scenario are used to having heat being pulled away from it. Even though we feel quite warm, our bodies are getting heat pulled out of it. So if you take us into a 98.6 degree environment, no body heat is being pulled away through convection or conduction, only by radiation. Radiation, that's that third means of heat transfer that I was mentioning. Radiation is where we lose heat without any contact from gases, liquids, or solids. So, in space, the only way for us to lose heat is through radiation. And seeing as our bodies are constantly churning out heat at 98.6 degrees Fahrenheit, we're going to feel uncomfortable. It's like sitting in a room that's 98.6 degrees Fahrenheit. But sitting in a room that's 98.6 degrees Fahrenheit won't kill you. Being in space will. Here's why. So, how do we lose our heat in space? One way. Radiation. Radiation is defined by Google as the emission of energy as electromagnetic waves. Now, we know that we can hear sound in space, but we can't hear sound in space, but through the use of an electromagnetic telescope, we can detect waves moving through space and convert them into sound waves that we can then hear. So, this means that electromagnetic waves can travel through space. That means we can radiate heat in space. But our bodies haven't evolved to radiate heat nearly as effectively as we have evolved to lose heat through convection and conduction. So in space, we will lose heat, just not at a rate that's fast enough to keep us alive, which is why we'll die. We'll overheat. So our bodies are meant to operate at almost 100 degrees Fahrenheit. If you take us out of an environment where we can do that efficiently, what's going to happen is our body is going to do everything it can to shed heat. However, without any convection to cool down the sweat on our skin and any conduction to pull away our heat fastly, we're going to die. Plain and simple, we'll get a heat stroke. So when our body has all this heat and nothing pulling it away, we're just going to keep making more and more heat, trying our hardest to lose said heat, but nothing's going to work. So you're dying of heat stroke. First step, don't panic. Second step, you can't panic, because your brain is being fried. When your body reaches an internal temperature above 104 degrees Fahrenheit, it's time to get into an ice bath. But with no ice to conduct away the heat from your body, you're up a creek, buddy. So, time to say your prayers and hope for the best. What happens is your brain is going to lose consciousness, blood pressure will fall, heart rate will increase, and you're going to do severe damage to just about every vital organ in your body. And then you die. And then what? You float around in the vacuum of space, dead. But you're not going to stay hot. No, your body won't stay 104 degrees in space. Instead, your body is going to slowly lose heat through radiation. And this is the part where you freeze. See, you're going to die of heat stroke, but your body will be found frozen over the next few days. As you radiate the heat away from your body, your blood will slowly freeze, and you will just be a frozen carcass floating around in space. Comforting. The good news is, this has never happened. No human has ever died in space and then stayed in space. There have been a few that have died on re-entry from space, and it's hard to determine whether or not they died in space or in the exosphere. But every single person who has gone on a space mission and died on the way back has been brought back home. So, we know that at least if your frozen carcass is found, you'll be laid to rest. But let's just play with the hypothetical game a little bit more. What if you weren't found? What if your frozen carcass was just floating in space for the rest of eternity? You'd be decomposed, right? Well, no. Because you don't have any fungi on you. You don't have any mold. You don't have any mushrooms, at least you shouldn't. And you would just float around, not being digested, perfectly preserved in outer space for the next several billion years. On that dark note, let's focus on something a little more bright, the planets. Make sure you get out your telescopes tonight because you'll be able to see Venus, Mars, Jupiter, and Saturn. A couple nights ago, my sister and I got to see the rings of Saturn and the spot on Jupiter. So make sure that you are in an area with good visibility and you can see all four of them. Make sure that you look somewhere between the southern and western horizons. Thank you guys so much for watching. This has been Astronomy, September 28th, 2018 with Christian Harris. Y'all have a great evening, and happy stargazing!